Greetings, ladies and gents, and welcome back. It's Mike Maths and Science Club. In this video, we'll be looking at a question which was written in November 2021. So it's a question on cubic function. So they say that the graph of f of x, which is equals to 2x cubed plus 3x squared minus 12x, is sketched below. They say that a and b are the turning points of f. C, which is 2 is to 4, is a point on f. So for 9.1, they say that determine the points, the coordinates of A and B. Now, of course, they told us that those points A and B are actually the turning points of those graphs. Now, of course, to get the turning points, the first step would be to take the equation, of course, the turning points of a cubic function. So what you would do in this case would be to take that equation, the equation of that cubic graph, and then you take the first derivative, and then what you would do in this case, you would equate that to 0. In this case, you would, of course, calculate the x coordinates of those turning points. So what I'm going to do, that's exactly what I'm going to do. I'm going to say that we know that, of course, f of x is actually equals to 2x cubed plus 3x squared minus 12x. So that would be the equation, right, which we have there. So what I'm gonna do, I'm gonna find the first derivative of that, and then I'm gonna equate it to 0. So in this case, I know that what I'm gonna do, so I have the first derivative. So in this case, what I would do in this case, I would take that power and multiply it by the coefficient of x, and then I would just be subtracting 1 from those powers. So in this case, for the first one, so in this case, I'll take 3 multiplied by 2, that would give me a 6, and then in this case I subtract 1 from that power, so 3 minus 1, this would give me a 2, plus 2 multiplied by 3, that gives me a 6. That doesn't look like a 6 now, so this would give me 6 x. So remember that was 2, we subtract the 1 from that, that gives us a 1, and then in this case for that we will take, now remember we have 1 there, so 1 multiplied by negative 12, that's negative 12, we subtract the 1, so that becomes x to the power 0. Anything to the power 0 is actually 1, so that 1 would be multiplied by negative 12, and again we'll still get negative 12, so this would just be negative 12. So in this case, what I'm going to do, I'm just going to take that, I'm going to equate it to 0. So in this case, what I have would be 6x squared plus 6x minus 12 being equals to 0. So in this case, I'm just going to divide by 6 on both sides, on all my terms. So in this case, what I would have would be x squared plus x minus 2 being equals to 0. So in this case, what I'm going to do, I'm going to factorize. So in this case, the factors of x squared would be x and x, and of course of negative 2 would be 2 and 1. Now in this case only for 2. Now remember that that is actually negative, so in this case one of these numbers must be negative, but I don't know which one. Now what you would need to do, now remember this multiplied by that would give us x squared, and 2 multiplied by 1 would actually give me a 2, but remember that one of these must be negative, right? But in this case I don't know which one would be a negative. So what I'm gonna do, I'm just gonna assume that that 2 is actually negative. So in this case, I'm gonna give a negative to that 2. Now, what you must have in this case would be, when you cross multiply what you have on that Cartesian plane, you must, when you add whatever you get, when you add them, you must actually get that middle term. So in this case, negative 2 multiplied by x, it will give us negative 2x, and x multiplied by 1, that would actually give me plus x. So in this case, when I add this up, I would actually get negative x. Now this won't be ideal. Why? Because it doesn't give us the negative, it doesn't give us the middle term. So what I'm gonna do, I'm just gonna switch things around. I'm gonna give that negative to that to 1. So in this case, I'm gonna treat that as positive, so this would be negative. And of course, I'm just gonna do the same thing. So in this case, I would have 2x minus x. If I cross multiply that, in this case, when I add this 2, I would actually get x. So in this case, this would be what my factorization should look like. So in this case, I should have x plus 2 all multiplied by x minus 1, and then you equate that to 0. So in this case, what you would do next would be to take x plus 2, equate it to 0, or x minus 1 being equals to 0. So in this case, so x, you would find that's negative 2, or x must be equals to 1. So in this case, we know that this point actually have a positive x coordinate, and this and a actually have a negative x coordinate. So in this case, we would know that the coordinate, the x coordinate of b would be 1. Already, we don't know the corresponding y value. Alright, so in this case, for a, we would have negative 2, but also we do not know the corresponding y coordinate for that. So in this case, what I would do, so what you would do next would be to take these x values that you got, and you substitute them on that original equation to find the corresponding y values. So in this case, what you would do, so we have f of x, so you have f of x. So what I'm just gonna substitute that. I'm gonna first start by when x is equals to negative 2. So in this case, I would have negative 2. All of this is so this would actually be, so where there's x on that equation, I would actually put negative 2. So in this case, I have 2 multiplied by negative 2 squared cubed plus 3 negative 2 squared minus 12 negative 2. So in this case, let's just put that in the calculator. Let's see what we get now. So we have 2 negative 2 cubed, all right, plus 3 negative 2 squared minus 12 minus 2. I can actually just see that that was supposed to be cubed, not squared. So we have that would be 3. So what you would actually get would be, so when x is negative 2 on that function, on that equation, so in this case, the corresponding y value would actually be 20. So this is when x is equals to negative 2. So for us to find the one also when x is equals to 1, so what you would do the same thing again. So let me just take another color. So in this case, this would be f at 1, not negative 1. So this would be 1. So this would be 2 1 cubed plus 3 1 squared minus 12 multiplied by 1. So in this case, what we have, I'm just gonna replace that with 1, and also this would be, so we'd actually get the corresponding y value to be negative 7. So this would be negative 7 when x is 1 on that function. So in this case, what you would have as the turning point would be, we know that for a now, a is actually negative 2. So in this case, the corresponding y value would be 20. And then, of course, b would be x is 1. The corresponding y value would be negative 7. So that's for 9.1. So that's how you would get actually those that 5 marks. So I'm just gonna erase this again. So we found a, so in this case, let me just substitute that on our graph. So this is 20, and that would be negative 7. So let me just erase that such that we have so that we have somewhere to write. So what we have now, so for question 9.2, they say that for which value of x will f be concave up. Now to find the concavity, what you would do in this case, now remember when you, so the shape in this case, when your graph is concaved up, so what you would have would be something like that. So it would be something like that. So this is when your graph is concaved up, and then when it is concaved down, you would have a maximum a maximum turning point. So in this case, this would be the minimum. So in this case, what you would do to find the x values, of course, for which your graph is concaved up. So in this case, what you would do would be to take the second derivative, right? The second derivative, and then in this case of f of x. So in this case, you would actually it would be greater than 0. So in this case, when it is concaved down, so in this case, your second derivative would actually be less than 0. So this would be, of course, when you have a minimum point, and this would be when you have the maximum point. So in this case, what we're gonna do now, remember they said that for which values of x will f be concaved up. So in this case, what we're gonna do, we're gonna take the second derivative, and then of course we can set it to greater than 0. So in this case, what you would have now, remember, so what I'm gonna do, so we have f of x being equals to 2x cubed plus 3x squared minus 12. So in this case, to find the I'm just gonna find the first derivative first. So in this case, what I have would be 6x squared plus 6x. Now remember, this is actually x. So in this case, this would be minus 12. So this is the first derivative. So in this case, the second derivative would actually be the derivative of the derivative. So in this case, it's the second derivative would be 12x plus 6. So remember that when you derive let's say a constant, you actually get that to be 0. So this would actually give us a 0, right, when we of course go to on that second derivative. So in this case, now remember we said that of course to find when your graph is concaved up, so in the x values in this case. So what you would do in this case, you would take the second derivative, and of course you would set it to greater than 0, right, being of course greater than 0. So this would be greater than 0. So in this case, what you do, we have 12x plus 6 being greater than 0. So in this case, what I'm going to do, I'm just going to transpose that 6. So in this case, what I have would be 12x being greater than 6, negative 6. So again, I'm just going to divide by 12 on both sides. So what I would have actually would be x being not equals to, so in this case, this would be greater than negative a half. So this, of course, so in this case, your graph would be concaved up when x is actually greater than negative a half. When of course the x when x in this case would be is greater than negative a half. So for 9.3, they say that determine, so if they had asked for the when is of course your graph concaved down, so what you would do, you would take the second derivative and you equate it to less than 0, right? So in this case, you solve for x, and then again you would get the your x your x values there for which your graph would be concaved down. But in this case, for 9.2, they actually asked for which values of x will f be concaved up. So in this case, for 9.3, they said that determine the equation of the tangent f at c, which is 2 is to 0. Now again, I'm just gonna erase what I have, right, so that of course we have somewhere to write. I hope I hope I'm explaining it better. I hope you learned something. So in this case, for 9.3, they say that determine the equation of the tangent at f of to f at c. So we have a tangent that is passing through, and just take that, so that is actually passing through that c. All right, so we have a tangent there. Now remember that a tangent, it touches that graph once. All right, now this would not be realistic again. So in this case, we know that that tangent that we have, it is actually touching that graph once. Now remember that to find the point of tangency, so in this case, what you would do in this case would be to take this first derivative, and in this case, what you would do now to find the point of tangent, what you would do, you would take the first derivative. If you, of course, you are given the average, the gradient at that point. So what you would do in this case would be to say f of x. Now we know that this is equals to 2x cubed plus 3x squared minus 12x. So in this case, what you do to find the point of tangency, so what you do, you take the first derivative, and then in this case, if you are given the average gradient, so at that point, so in this case, this would be, so this would actually be equals to, so in this case, this would be 6x squared plus 6x, right, minus 12. So if you were given the gradient at that point, so what you were gonna do, you were gonna put that gradient right there, and then in this case you would find the x coordinate of that point of tangency. But in this case, they actually gave us the x coordinate of that point. So instead of us, if we, of course, if we were given that the gradient, right, and then we were looking for that point of tangent, what would have done was would have been to find the x coordinate, right? But in this case, what we're actually given the x coordinate of that point. So what you would do in this case to find the average gradient, the gradient at that point would be, now we're actually given the x coordinate at that point. So in this case, you would so this would be 6 multiplied by 2 squared plus 6x 6 multiplied by 2 minus 12. So in this case, let me just take out the calculator. So what we have would be, we have 6 multiplied by 2 squared plus 6 multiplied by 2 plus, that's minus 12. So we actually have an average gradient of 24. So we know that, of course, the average gradient in this case, when the average gradient to, so this would be actually equals to 24, if I'm not mistaken. So that's 24. So in this case, we know the gradient of that line. So in this case, we know that the gradient would be 24. So in this case, the equation would be y is equals to mx plus c. But now we know the gradient right at that point. So in this case, this would be y would actually be equals to 24x plus c. So in this case, now remember, to find c, what you would do in this case would be, I'm just going to take that point there, I'm going to substitute it on that equation. So what I have is y being equals to 4, so that's equals to 24 multiplied by 2 plus c. So in this case, this would be 4 minus 24 multiplied by 2 being equals to c. So what I have there would be minus 4. I have actually 4 minus 24, all that multiplied by a 2, if I'm not mistaken. So that's the 2 there. So in this case, you would actually get c to being negative 44. So of course, so the equation for that the equation of the tangent at to f at c, in this case, would have the equation which says y is actually equals to 24x minus 44. I hope I've been helping. I hope I hope I explained better to some point. But otherwise, this is actually the end of this video. If of course this video helped you at some point, be sure to hit that like button. And of course, if you haven't become part of this growing community, be sure to hit the subscribe button, and also that notification bell, so that when I send more videos, so that you can be notified. But as the story always ends, ladies and gentlemen, this is Sir Mike signing out. Sharp sharp.